differentiation or example. Let's look at one of the examples. If y is equals to sine inverse of x, then find the y all over the x. Okay? That's clear? In this video, we are going to look at this function. This is a inverse function, differentiation inverse function. We said if y is equals to sine inverse x, then find the y all over the x. Let's write solution. Okay? Solution. Now y is equals to sine inverse x. Yes, I want us to know and understand something here. I know very well that if we want to write inverse of x, that is, note that, sine inverse. Sine inverse is the same thing as 1 all over sine, or this is the same thing as sine inverse. Please take note. Is that clear? But now we have sine inverse x. So this implies that this is the same thing as x all over sine. Is that clear? So please take note. Take note. Okay? If you agree with me, let's look at so if you agree with me, we'll now write, note that sine inverse x is the same thing as x all over sine. So it implies that our y is equals to x all over sine. Then what do? We are going to cross multiply. We cross multiply, that is, it implies that there is an invisible one here. It means this guy, this one will multiply x, then this side will multiply y. Is that clear? So if we cross multiply, we are going to have sine y is equals to x. Is that clear? So at this point, we will differentiate both sides. We will be using d all over the x, all in bracket, sine y, close bracket, equals to d all over the x, open bracket, and close. So this implies that differentiate what is inside here. Are you following? So if we are to differentiate what is inside here, it implies that if we differentiate sine y, here we are going to have cos y dy, because this implies that we differentiated for y, dy all over the x. Then this is equals to differentiate what is inside here. So here will give us 1 times the x. It implies that you differentiated for x all over the x. Are you following? Okay. So if you agree with me, amen, if you agree with me, if you can see what I am saying, note that if we have the x all over the x, this is the same thing as 1. Just like 2 divided 2 is equals to 1. Amen? So if you agree with me, it implies that 1 times 1 will still give you 1. It implies that our cos y dy all over the x is equals to 1. So since we are to find dy all over dx, what we need to do, we divide 2 by cos y. It implies that our cos y all over cos y dy all over x is equals to 1 all over cos y. Is that clear? So this and this will go. Therefore, our dy all over dx is equals to 1 all over cos y. Amen? Okay. If you agree with me, we will not stop here. We know that our dy all over dx is equals to 1 all over cos y. We will not stop here. Go back to your trig. Amen? Your trig. We know at this point you introduce this, we know that cos square theta plus sine square theta is equals to 1. True or false? Since we are not talking about angle, since here is y, so instead of theta, we are going to write cos square y plus sine square y is equals to 1. Do you agree with me? So if you agree with me, it implies that we want to come up with something. It implies that we are going to make y cos y the subject of the formula. So if you agree with me, it implies that our cos square y is equals to, if sine square y crosses the sign of equality, becomes minus. So 1 minus sine square y. Amen? Okay? So if you agree with me, our it means we are going to square both sides. Square both sides. If we square both sides, we will have cos y equals to square root of 1 minus sine square y. Amen? But let us try to do something. Amen? Let us assume, or let's have sine y equals to x. So it implies that if we let sine y equals to x, it means here our cos y is equals to square root of 1 minus, since sine y is equals to x, it will now be x squared. Is that clear? Do you understand? Any question? So if you agree with me, our cos y is equals to 1 minus, square root of 1 minus x squared. Then come back here, where we know that our dy all over dx is equals to 1 all over cos y. So if you agree with me, it implies that our dy all over dx, therefore our dy all over dx is equals to, since cos y is equals to this, we have our final answer. Y